Hello and welcome to our decentralized ventilation units. Great that you are our guest today. An easy and efficient solution for any application. My name is Willy Konstantinov. I am the product and key account manager here at Zehnder Sales International, and with me today.
Hello everybody, my name is Adrian Good and I am working as a technical projects engineer at Zehnder Group Sales International, and I'm very happy to have you here today. We have a great topic and I think start now.
Great. Okay. So firstly, let's have at today's presentation targets. So we will speak today about the difference of central and decentral ventilation units. Well, why using decentral solutions? Then Adrian will talk more in detail about device technology, about the controls and different air quality sensors. And we go then a little bit more deeper in detail about mounting and installation, and also we'll mention the topic maintenance, what's important up there to be considered. So moving on, and let's get started. And here, just for you to show of today's webinar and today's presentation. So as we announced, we will talk about our decentralized solution from Zehnder, and we will focus our webinar today on our Comfort Spot 50 and Comfort Air 70. That's the product names centralized solution, and just a few key points about that units. Has a maximum air volume flow of 50 cubic meters. It has 4 fan speeds, 15 to 50 cubic meters per hour. A low power consumption of 15 watt max, very quiet 29 decibel sound pressure level. Both units have around 19% of heat recovery, but also a very high percentage of moisture recovery. Comfort Spot 50, 70 up to 74%, and the Comfort Air 70, 84% of moisture recovery. Also, a very good point, we will talk a little bit later about the window reveal module. I will not talk so much about that now. You will see it later. And the Comfort Air 70 with its room connection that will also Adrian explain a little bit more about later.
Yeah.
So the difference in central versus decentral. So many of you definitely know there's the difference of air volume, but that's not the only significant difference, as decentral solutions can also have units with high air volume or higher air volume. But the main difference we pointing out is that ventilation via one central ventilation unit is transporting supply and extract air through the whole building using an air distribution system, as you can see in the picture on the left-hand side. And the decentral solutions, well, it's one or several decentral ventilation units exchanging supply and extract air in a building section, room, or an apartment, mostly without using any air. So also where it's applicable, well, there's also a wide range of applications where you actually can install and use a decentral ventilation unit from Zehnder. As you can see here in this graph, you can put it in a new build, but you also can put it in a renovation. And this is a topic where we focus also our webinar today. As we know, by 2050, we want to be CO2 neutral, but the buildings by 2050 are 80% of the buildings we already live in. So the renovation sector is very, very highly demanded, and therefore we need also air ventilation solutions for that renovation sector. So it can be used commercial or residential. And just to put it on one glance in a very easy way, you building section where only a section of a larger building has to be ventilated in a smaller or small apartment, which also is a kind of section of a building, or when only a room requires ventilation. So just to put it again, everything together, and point out a few characteristics of the renovation and a new build. So in renovation, you can use a decentralized solution when air distribution is not possible of many reasons. There's no space, or if you would put, or you don't have, if you would put them into under the ceiling, then your space between the floor and ceiling significantly, so not enough space would be left for the habitants. Or if installation of a central ventilation unit is not possible, or if apartment owners require individual solutions so that they want to own their ventilation system, or if only a room, a building section, or a small apartment requires ventilation. So also on the new building side, on a new build, also apartment buildings with need for individual ventilation, when ventilation without air distribution is required for any reason. Smaller spaces like dorms, hotels, hostels and hotels, and small houses and apartments. So now I hand over to Adrian, and he will talk a little bit more in detail about the function and the technology.
Yeah, thank you, Willy. So let's get into a technique of our decentralized units. So basically, we have the same components like in a central unit. We have 4 airflows, beginning with the green one, which is the outdoor air, going through a filter, then going through the heat exchanger, and then it's supplied into the apartment. As you can see, the blue airflow. On the other hand side, we have the extract air, which is also going through the heat exchanger, giving off the heat to the supply air, and then is blown out as exhaust air. So our decentralized units have 2 fans which work simultaneously. So we get a continuous supply and exhaust air volume. And therefore we get a permanent heat recovery, and at the end we have a high efficiency and a high comfort. And we have a temperature sensor in the outdoor air for our frost protection control. Explain this later on. And then we have the heart of the unit, the heat exchanger, shown in blue, and which are on a G4 level, but for the supply air you could also use a F7 filter. And at the inner side of the unit, we have automatic flaps which close the air channel when the unit turns off. And there we can avoid any uncontrolled airflows through our unit. And this is how it looks like in detail, starting with the outer cover. This is available in plastic, aluminum white, or stainless steel. And you can also paint this outer cover. So if you have a blue facade, you can paint that cover blue. And then we have the mounting tube as an installation kit, and inside the EAP housing, which basically includes the whole technique. So the heat exchanger, the filters, and the control. Inside we have the inner cover. This is what you can also see here. This is a Comfort Air 70. This is how it looks like from the inside. And here you can also see that the grills are of the unit on each side. So on one hand side we have supply air, on the other hand side we have extract air. And I want to point out here that people sometimes think that there is a recirculation, but due to the orientation to the side, we make use of the Coanda effect. So the air streams at a wall and then it spreads into the apartment. So there's no recirculation. And the same effect is used at the outside, so that there's no recirculation from the exhaust to the incoming air. Now we can take a closer look at the heart of the unit, the enthalpy exchanger. So our decentralized units come by default with an enthalpy exchanger. So this is not a normal heat exchanger, which only recovers heat. An enthalpy exchanger also recovers humidity. So in total, we have a higher recovery efficiency because we are using the sensitive and also the latent energy which is in the air. And therefore, we are using a cross-counterflow heat exchanger, which consists of a selective polymeric membrane. And through this membrane, only heat and moisture can be transferred. No gases, smells, or other contaminants can be transferred through that membrane. Now let's imagine what happens in winter when the outdoor air is absolutely seen dry, and indoors we have a more humid air. And if we would just take in that dry air and even heat it up because it's cold, the indoor climate gets quite dry and uncomfortable. And using an enthalpy exchanger, the humidity goes from the humid inside air through the membrane of the exchanger on the side of the supply air. And then we get a comfortable indoor climate. And the same applies in summer. There it's the other way around. So we always have both airflows aligning to each other. And this results in humidity level throughout the whole year. And yeah, the comfortable range is between 40 and 60% relative humidity. Another benefit from the use of an enthalpy exchanger is that there's no formation of condensate because you are transferring the humidity. So you have no water at the outside of the facade, and you have therefore no risk of freezing at the outside. And additionally, a standard heat exchanger can only be driven till 0 degrees. An enthalpy exchanger can operate in a normal mode till -5 degrees because there's no risk of freezing. What happens below -5 degrees? That's what I want to show you now. We also have automatic frost protection to protect the units from freezing at very low outside temperatures. So all these units are equipped with that automatic frost protection control. As I already said, the unit runs till -5 degrees in a normal mode. Between -5 and -15, we are adjusting the ratio between supply air volume and exhaust air volume. So we decrease the airflow while the extract airflow is on a constant level. So we have more warm extract air than cold supply air. So we are going into an unbalanced mode between -5 and -15 degrees. If the outside temperature drops further than -15 degrees, then the unit switches automatically into a standby mode to avoid any damage. Yeah, and this is done by the outdoor temperature sensor, which you have seen at the beginning. And then when it's in the standby mode, it checks automatically whether the conditions for frost protection has changed and is switched on automatically when the outside air or the outside temperature rises again. But take care by a joint operation with fireplaces. This could get very dangerous. So I would say I need to say that the joint operation is only allowed in combination with corresponding safety devices in compliance with regional regulations and standards, because it could happen in frost protection mode that under pressure in the apartment is produced because we are going into an unbalanced mode. And then we get a small under pressure. It's not much, but it could be enough to extract combustion gases from the fireplace into the apartment. And this can get very dangerous. So here you need to take care. Yeah.
Yeah, so be cautious with the fireplace if you have one. How can you control the decentralized ventilation unit? Well, you have a very convenient control at the unit itself, because this unit is installed in your living space, in your bedroom, in your kitchen, in your bathrooms, or so mainly you definitely have a very good access to this unit. And then it has a control directly placed on the unit with different functions and signaling. So you have 4 different selections of fan speed that starts with 15 at the minimum and goes up to 50 cubic meters per hour with a Comfort Spot 50 or 60 with a Comfort Air 70. It has a boost ventilation mode. If you choose different, or if you choose one of the sensor controls, CO2, humidity, or VOC, this unit can also operate in an automatic mode. Then it's demand controlled. It has a signaling for filter runtime. So if it's time to exchange the filters, it will also show you. And it have a signaling for error messages. So different errors could occur, and this is with the blinking LED. The unit also shows you that it's maybe time for a maintenance. So, but also you have a convenient external remote control panel, Comfort LED or Comfort LED, that you can place very conveniently together or close to your normal light switch. It is wired remote control, but you basically have on this remote control or panel the same functions as described in the slide before. It can be used with a standard blind frame of 55 times 55 millimeter, and it can be connected with a standard connection cable, for example, the model that you see in this slide. So then we have several air quality sensors that you can choose for a demand-controlled ventilation. You can choose between a humidity sensor, you can choose a humidity sensor and VOC sensor, VOC for volatile organic components, or a humidity and CO2 sensor. The humidity sensor will provide you optimal indoor climate. As we know, the comfort zone lies somewhere between 40 and 60% of humidity.
Hey, Willy, at this point, I would like to get the audience on board and check their knowledge from the previous webinars. So let's start a quick poll and check.
See if I also know something.
So how many liters are produced per person per day on average?
I can also participate, right?
50% of the audience has voted. 60. 80%, okay. Just a few more seconds that can take a guess. So you know we are producing moisture by breathing, taking a shower, cooking, cleaning, things like that. So now I think we can close this session. So 70% said 2.5 liters, which is actually the correct answer. 10% said 0.5 and 20% said 6 liters.
Okay,
so
that shows that
the right choice.
Okay, so Adrian, you know now that the previous webinars were visited or watched.
Yeah, good.
So good job, Adrian. Yes, so humidity sensor, but it can also be combined with humidity and VOC sensors. VOC is our volatile organic components such as building materials, textiles and plastics, perfumes, room sprays, and cleaning products, polish, nail polish remover, something like that. And or you can combine the humidity and CO2 sensors, which then will help to provide a healthy indoor climate with CO2 levels at a very healthy with CO2 at a very healthy level. As we know, from 0.1% or 1,000 ppm of CO2, it has a significant effect on our body, and we tend to get tired more quicker.
Yeah, so now I take over with the mounting, which is also quite interesting for you probably. Basically, you just need a hole in the wall and a 230 VAC power supply. And to get an idea how the installing is done, I would like to show you about the installation of a ComfoSpot 50. So here we are again. So you have seen in the video, but firstly you need to make a tapping drill hole with a horizontal axis. Then you need to shorten the pipe according to the available wall thickness in such a way that it is even with the plaster of the internal wall and with the wall surface of the facade. After fixing in the wall, fill the room between the masonry and the installation pipe with an assembly foam inside and outside. Shorten the core device, set it into the installation pipe in the wall bracket, connect it to the power supply, and then mount the design cover, and that's it. Here we can see different mounting options. So you have seen now the installation kit wound. That's a round wall mounting tube, which is 900 millimeters long. For the Comfort Sport 50, it has a diameter of 315 millimeters, and the Comfort Air 70 only 250 millimeters diameter. And the round tube is typically used for retrofitting. You just need to drill a hole in the outer wall and then set it into that hole. For new builds, we have an angular installation kit. So during the planning and construction phase, you can take that into consideration, and then you can build it in during the construction phase. The minimum outside wall thickness for our decentral units is 275 millimeters, and the EEP housing, which includes the whole technique, has a length of 600 millimeters, can be shortened to 275 millimeters, or even extended with the extension set up to 900 millimeters. So for any application, you will find a solution with these products. What we also have in our portfolio is the window reveal module. This is used to hide the outer wall grill in the window reveal, so that there is no grill visible at the facade. And this module comes along with the mounting tube as a whole set, and also with the shortenable channels and grills. And these channels are installed at the outer wall in the insulation layer. So at the end, you get a nice appearance. It's not noticeable from the outside. And as you can see, this is often used in a multi-story building to hide a huge number of outside grills in the facade. What we can also offer is a adjoining room connection. This is only possible for the Comfort Air 70. The window reveal module is for both units, but this adjoining room connection is only for the Comfort Air 70. And here you have the option to connect a second room with a little pipework. The unit has outlet sockets at the side and in the back, where you can connect an adjoining room. And this is often used, as you can see in the picture, for a bathroom. There you can see a Comfort Valve Luna E, an extract valve, which is connected to the Comfort Air 70 in the background, as you can see. But you can use it for any other application. You can also connect a supply air room or even both. So it would be possible to install the Comfort Air 70 in a utility room and then connect the supply air room, an adjoining supply air room, for example, a living room, and on the other hand side, extract air in the kitchen, for example. You can connect these rooms with our air distribution system, either with the Comfort Tube 90, which is a round tube, or our oval tube, the Comfort Flat 51, using an adapter to the unit, as you can see below. The maximum recommended length for that pipe is 10 meters. and there we calculate two 90-degree bands. Each additional band reduces the length round about 1 meter. But please note that this is still a very central unit, so this is actually not what it's made for. The small unit does not have the power and the pressure to overcome large distances. On the following slides, I want to show you some applications which are quite different. We have a single family house with a second room connection. So here we are using 3 Comfort Air 70, the working room with a second room connection to the toilet, in the utility room with a supply air connection to the bedroom, and in the living room there's another Comfort Air 70 with extract air in the bathroom. And also at the bottom of the layout you can see a Comfort Spot 50 in the kitchen, which extracts the air from the kitchen and blows in the supply air to the dining room. Another application could be a multi-family house, which is often done because there you often have a internal bathroom, and therefore this Comfort Air 70 fits perfectly. So for example, you have supply air in the bedroom, and then you connect the internal bathroom. So that's a typical apartment. Another application could be a student hostel. This is what we have done there. You know, all these small rooms with a desk, with a bed and a small kitchen in it, and an internal bathroom. So there you can connect the adjoining room connection to that bathroom. And another advantage is that every room is individual controllable. So you could also use this concept for retirement home or for hotel rooms. And there you can make it like that. If the rooms are occupied, you set it on nominal ventilation or on preset 4. And if they are not used, you can set it on preset 1 just to have a small exchange for humidity protection. So to protect your building structure from humidity damages. But in such cases, always take note of regional standards concerning the air volume flows and the fire protection and the sound levels. This needs to be taken into consideration in such cases.
Oh yes, should you install one of these decentralized solutions? I would say yes, you should. And if you still need something to be sure about on the secure side, we also have some certifications to show. Definitely depends always also on your local regulation, but these centralized units from Zehnder, they are Passive House certified, they are CE certified, and also here, as you can see, we have a European energy label, which also indicates the power consumption and the efficiency overall of this unit. So it gives you a quiet operation for maximum living comfort, exceptionally good indoor climate, high energy efficiency, and a maximum hygiene and a maximum climate comfort. But to guarantee this maximum hygiene and the high efficiency, you should also do something from time to time. And this is to maintain or carry out some maintenance that is required from time to time. As the two biggest points here are actually the filter maintenance, which is carried out every 6 months, and the maintenance of the enthalpy exchanger, that is the heart of the unit. Well, the enthalpy exchanger, you just take a look or maintenance it every 2 years. You can actually take it out and clean it in your bathtub or your shower tub. Just rinse it with water, then let it for a few hours, or best for a whole day, that you can make sure that it's definitely dried inside, and then you put it back in the unit. And with the filters, well, we have a filter indication LED that actually tells you when a filter should be changed, but we recommend every 6 months to change the filter to guarantee that you have clean air, that you have hygiene air, and that your decentralized unit is also working very well. Yes, so that is actually also almost the end of our presentation. Before we go to the Q&A session, where we hopefully will receive some of your questions, I want you to make aware of our next webinar coming already exactly in 1 month at the same time. And there we will talk about our Zehnder air distribution systems, Zehnder Comfort Fresh, and the hygiene air distribution. You can take your mobile phone and scan the barcode that you can see now in the slide, and you can directly register for our next webinar. So now we are at our last slide. Thank you for watching our webinar, Decentralized Ventilation Units. You can see our contact data in the slide for Adrian Good if you have some technical project questions, or you also can contact me if you have some product related questions. And now we are happy to answer any of your questions.
Yeah, there are a few questions. For example, what is the lifetime of a standard exchanger or an enthalpy exchanger? So this always depends how often, or if you have done regularly the maintenance procedure. So if you do it on a 2 years basis, cleaning the enthalpy exchanger and every 6 months you change the filters, then we say the lifetime is about 15 years. But if you don't do so, the lifetime could be shorter because the exchanger is contaminated. And there's no difference between a standard heat exchanger and an enthalpy exchanger. This applies for both. Another question is what happens if the outdoor temperature is 40 degrees. So if you have 40 degrees outside and you're sitting in your apartment, you still need to have an exchange, because you know, if people are in the building, the CO2 level goes up and you still need some exchange. And if you have 40 degrees, then sure, you take in the warm air, but you still need an air volume exchange. And then you need to think about an active cooling system or something like that to hold the temperature inside on a comfortable level.
But what's also important maybe to add here, if you have 40 degrees, depending on the area where you are living, your air could also contain a huge amount of humidity. And what's also important to mention out, having this humidity coming from outside, the principle that Adrian just explained before, how the enthalpy exchanger works, is actually that by the warm humid air entering your unit, a portion of that humid will be transferred through the enthalpy exchanger through the exhaust air, and then your air entering your apartment or your room is already a little bit dehumidified, so which also gives you a relief about the temperature that you feel.
Yeah. And there is almost the equal question, but the other way around. What happens at minus 20 degrees outside? Yeah, there our force protection control is starting. So at minus 20 degrees, the unit turns off because there would be a risk of freezing the heat exchanger, and that could damage the exchanger. We do not have a preheater for our decentralized units because it's too small. There's no space for a preheater. So at minus 20 degrees, the unit is in standby mode. It only works till minus 15 degrees. There's another question. Is it feasible to install the system in a wall that is thinner than 275 millimeters, so around 230 millimeters? Yeah, you could also do that, but then, you know, the unit in the inside is looks into the apartment, but you can build something on the inner wall to hide this. So it would be possible, yeah, but you cannot hide the whole.
You just need to fill up somehow the distance that or the space that is missing for the minimum thickness.
Yeah.
In the size of the unit, to fill in with some material to fill the space that is missing.
Yeah. So there are a few more questions, but I don't think we have the time now to answer all of them. So I would say we note down these questions and come back to you via email. And if you have any further questions, you can always contact us. We are happy to assist you.
Okay, look, we are very good in the time. So we announced that the webinar will take place until 4:45 p.m. And thank you very much for your time for this 45 that you gave us today. I hope it was very informative for you. As Adrian already mentioned, you still can reach us via email, and the remaining questions that are still in the chat, we will definitely address them individually to you. Thank you very much, and see you next time.
All right. Thank you. Goodbye.